Hello everyone, let's talk about another easy problem on Leetcode today. Relative sort array, Leetcode 1122. In this, we are given two arrays, array 1 and array 2, and the elements of array 2 are distinct, and all the elements in array 2 are also in array 1. So then we have to sort the elements of array 1 such that the relative ordering of items in array 1 are the same as in array 2. Elements that do not appear in array 2 should be placed at the end of array 1 in the ascending order. So then they have given some examples. In example 1, we can see that our array 1 is 2, 3, 1, 3, 2, 4, 6, 7, 9, 2, 19. Now we have array 2. In this, we have 2 as the first element. So we move all the three 2's at the start. Then the next element is 1. So we move it just after 2. The next element in array 2 is 4. So we can see that we have only one 4. So we will also move it after 1. So then we have 3. Now we see that 3 occur 2 times. So we will move all the 3's in the start. Similarly, we will move 9 and 6 as well. And then 7 and 19 were not present in array 2. So in that case, we will just sort them. Luckily, they were already sorted here. But if like 19 was earlier and then 7 was later on, we would have anyway sorted it and then add it to the remaining array. And that's how we will sort the array 1 based on the input from the array 2. Now let's jump into the solution space. The easiest way to solve this problem is using frequency map for array 1 and then ordering those elements based on the array 2. We use frequency map for array 1 because if you see 2, in the output, all the 2's come together. So if we go and check 2 for all the elements here, that will take O of n time just to get it. So better thing is to create a frequency map and then the lookup for the element in the frequency map takes just O of 1 time. First thing is we will create a frequency map. So we can see that 2 occurs 3 times and 3 occurs 2 times, 1 occurs once, and similarly whole frequency map is built. Then the next step is we can actually sort the elements based on array 2. Let's see how. So what we will do is we will start iterating the elements in order in array 2 and check the counts of it. So for example, first element is 2. So we see that 2 occurs 3 times. So we will create present array because all these elements that we are now creating is actually present in the array 2 as well as array 1. First three elements were 2 that we added to the list. So now next element in the array 2 is 1 and 1 occurs only once. So we will just add 1 to the present array now. Now the next element in the array 2 is 4 and 4 also occurs once. So we will just add 4 to the present list. Then 3 comes in, 3 occurs twice. So we will add 2 3's here. Now 9 and 6 come in and because they occur only once, so we will just add them here. So now our present array has all the elements in the sorted order, which are also present in the array 2. Then the next thing is we fill in the non-present elements. So now for the not present element, we will again do the same thing. We will actually go through the keys of counts array and match them with array 2. And we find out that actually 19 and 7 are actually not present in array 2. So those are the values now we have to populate in our answer. So let's call it not present. And we get 7 and 19. We sort the values. Luckily, they were already sorted. But if they are not, we will just sort this array. Finally, we will just append not present array into the present array, and that will give us our answer. So this was one approach. In terms of time complexity, because of sorting, it will be O of n log n. When we are building the frequency map, that takes O of n time. And then when we are going through all the keys, again, it takes O of n time to build the present array. And when we are sorting the not present array, that takes actually n log n time. So overall time complexity is n log n. In terms of space complexity is O of n because we are storing the values in the map. So that takes O of n time. Then we have two arrays present and non-present. So they again take O of n space. So overall the space complexity is O of n. But can we do better? And the answer is yes, because let's look at the constraint. So we can see that the constraint is that the array length can be between 1 and 1000 and value of any element in the array 1 and array 2 is between 0 and 1000. So that means we can actually use a bucket sort. And the reason for this is if you remember the previous method, the time complexity was n log n because of the sorting. So to make it faster, we can actually use bucket sort, which takes O of n time. But the problem with bucket sort is if the number of buckets is huge. For example, in Java, if we sort all the integers, then the number of buckets will be equal to the range of integers, which will be around 4 billion buckets. And that would definitely make our code very slow. But here, the good thing is that number of buckets for us is just 1001 if we include zeros number as well. Now let's see how we can actually apply the bucket sort algorithm. So first thing we have to do is like we will just initialize 1001 buckets. So these are all zero initially. Now we will start filling in these buckets with the frequency of different elements, similar to what we did with the frequency map earlier. Initial array is same as what we were seeing in the example one. And then when we run the count on those numbers, then we will see that 0 occurred 0 time, 1 occurred once, 2 occurred 3 times, then 3 occurred 2 times, 4 occurred once, and similarly we will fill rest of the buckets. So 0, 1, 2, 3. The indexes in the count array are like buckets, and the array values are actually the frequency. Once we have done it, next thing is we will sort using the array2. So what we have to do is we will just go through element by element in array2. So first element for us will be 2. So we can see in the count array or in the bucket 2, we can see that there are 3 values present, and we can set those 3 values in the array1 itself. The reason is that we have already created the count array from array1, and we can reconstruct it anytime we want. Of course, in this problem, we are not required to reconstruct. So we can just modify it in place so that we don't have to use any extra array or anything. So we set the first 3 indices as 2. Then the next element in the array 2 is 1. So we will set that value here as well. Now we see value 4. So we will now take the count 4. So count 4 for us was equal to 1. So now we will add 4 also to the array. Now we see element 3, and in bucket 3 we can see that we had 2 threes. So we will just append those 2 threes, and likewise we will fill in the whole array. What will not be still filled is like you see that 7 is now out. At this point 7 is not even visible, but we don't have to worry about it because we already have it in our bucket. So you can see that, for example, 19 is stored here, or 7 also, like 0, 1, 2, 3, 4, 5, 6, 7. So this is 7. So we still have it in the count array. We don't have to worry about it. So we have filled in all the elements which were present in array 2 in our array 1, and last 2 elements are still needed to be filled. So now we will sort the remaining elements. We will again loop through the count array and see if there are non-empty elements. That means those elements have not been yet processed and they were not present in array 2. So now that were only 7 and 19, and we only had one each of them. So we will now just set them at the end of the array, and then we are done. And that will be our answer. So now let's implement this algorithm in the code. First thing we will need is the count array or the bucket array for 1001 buckets, 1001 buckets. Now we will start looping on the array 1 and set the frequencies of its elements in the count array. Now we will start looping on array 2 and see if the value is already present. If it's present, then we will start setting it up in the array 1. We can reuse it, so we will need a different iterator for that. So what we will do is, like, if the number is present in the bucket and it's non-zero, that means we can reuse the frequency from it. We will just set it in the array 1 as num. So this will sort all the elements based on the ordering from array 2. Now we have to loop on the remaining elements, which we didn't encountered in array 2. So we will see if any element has frequency still not equal to 0. We will just use it and set it in the array 1. We can reuse the old iterator I here for the continuity, and array 1 will be our answer. Now let's run this code. Cool. Let's submit it. Awesome. So it just took 0 milliseconds. In terms of time complexity, it is O of n, where n is the number of elements in array 1. Because first we are creating this frequency map that takes O of n time, because we are looping on array 1. Then when we are setting the values in the array 1, if you notice, iterator I actually goes from 0 to length of the array, which is n. So again, it will be O of n. And in terms of space complexity, because we are using count array, in the worst case, if all the elements are not same, then it will be O of n. I hope this video was useful to you. If it was, please like and subscribe. The code and explanation for both the approaches are in the video description. Have a nice time. Thank you.